Space is silent. That is what we are taught, what we assume, what seems obvious the moment you think about it. There is no air in the vacuum of space. No air means no sound waves. No sound waves means no sound. Total, permanent, absolute silence. Except that is not entirely true. And the moment scientists discovered just how untrue it was, they uncovered something that has unsettled even the most experienced researchers. Something recorded not with microphones, but with instruments designed to detect radio waves, plasma vibrations, and electromagnetic pulses. Signals that exist far outside the narrow range of frequencies human ears can naturally perceive. But here is the unsettling part. When scientists translated those signals into something we could actually hear, shifted them down into the range of human hearing, slowed them, processed them, what came out was not random noise. It sounded like screaming, like groaning, like something breathing in the dark, like a presence. NASA has released several of these sounds publicly over the years, recordings from spacecraft near black holes, recordings from the plasma field surrounding Saturn, recordings from the magnetic environment of Jupiter, and one recording in particular, captured near the center of our own galaxy, that has been described by the very scientists who study it as deeply, viscerally disturbing. Not because it is supernatural, because of what it represents, because the sound itself is a translation of forces so powerful, so violent, so completely indifferent to anything alive, that hearing them, even in this safely processed, scientifically sanitized form, triggers something ancient and instinctive in the human brain, a sense that something enormous and hostile is very, very close. This is the story of the scariest sound ever recorded in space. And to understand why it terrifies even scientists, you first need to understand how something with no air, no atmosphere, and no sound waves can produce anything resembling sound at all. To understand the sounds of space, we have to redefine what we mean by sound. On Earth, sound is a mechanical wave, vibrations traveling through air, water, or solid matter. Your eardrum detects these vibrations. Your brain interprets them, and the result is the rich auditory world you experience every day. Voices, music, wind, rain. In the vacuum of space, there is no medium for mechanical sound waves to travel through. A scream in deep space would genuinely produce nothing, no vibration, no wave. Nothing for any instrument, biological or mechanical, to detect through traditional acoustic means. But space is not actually a perfect vacuum everywhere. In certain regions, particularly within the magnetic fields and plasma environments surrounding planets, stars, and galaxies, there is enough charged particle activity to create something different. Not sound waves in the traditional sense, but electromagnetic and plasma waves. Oscillations in electric and magnetic fields, vibrations and streams of charged particles moving through space. These are real physical phenomena, measurable, detectable by specialized instruments aboard spacecraft. NASA missions like Voyager, Cassini, Juno, and the Parker Solar Probe carry instruments specifically designed to detect these electromagnetic emissions. Plasma wave instruments, radio wave receivers, magnetometers capable of detecting fluctuations in magnetic field strength as a spacecraft moves through different regions of space. The data these instruments collect comes back as electrical signals, numbers, graphs, frequency measurements that in their raw form are not sound in any way a person could perceive. But scientists discovered something fascinating. Many of these signals occur at frequencies remarkably close to the range of human hearing, or can be mathematically shifted into that range without distorting the underlying pattern of the data, a process called sonification. Sonification is not artistic embellishment. It is not Hollywood sound design. It is a scientifically rigorous technique that converts data into audible sound, while preserving the actual structure, rhythm, and pattern of the original signal. When scientists apply sonification to data from Jupiter's magnetosphere, you hear something like a deep, droning hum, occasionally punctuated by sharp crackles, the actual electromagnetic signature of charged particles spiraling along Jupiter's enormous magnetic field lines. When applied to data from Saturn's rings, you hear something like static and chimes, the radio emissions generated by the interaction between Saturn's magnetic field and the icy particles of its rings. These sounds are real. They are not invented. They are not exaggerated for dramatic effect. They are translations. Authentic, scientifically accurate translations of forces that exist whether or not anyone is listening. And one such translation, pulled from the heart of our own galaxy, produced something that the scientific community was not fully prepared for. At the center of the Perseus galaxy cluster, roughly 250 million light-years from Earth, there sits a supermassive black hole of extraordinary scale. In 2003, NASA's Chandra X-ray Observatory detected something remarkable in the hot gas surrounding this black hole. Ripples, pressure waves moving outward through the superheated plasma that fills the space between galaxies in the cluster. These were sound waves. Real, genuine, physical pressure waves, the same fundamental phenomenon as sound on Earth, just traveling through plasma instead of air, and at a frequency far, far below anything a human ear could ever detect. The note these waves produced has a pitch. Scientists calculated it precisely. It is a B-flat, 57 octaves below middle C. To put that in context, the lowest note a healthy human ear can perceive is roughly 20 Hz. The note coming from the Perseus black hole has a frequency of about 1/10 billionth of a hertz. A single wave cycle of this sound takes approximately 10 million years to complete. It is, quite simply, the deepest note ever detected in the universe. When NASA scaled this sound up by trillions of times to bring it into the audible range, preserving the relative relationships between frequencies, simply compressing the absurd timescale into something a human can experience in seconds, the result was something that genuinely unsettled people who listened to it. A deep, resonant, moaning drone, rising and falling with an eerie, almost organic quality. Not mechanical, not random, something that sounds disturbingly close to a groan. A low, sustained, agonized exhale stretched across impossible timescales. It does not sound like static or noise. It sounds like something breathing. Scientists who study this sound are quick to point out that there is nothing supernatural happening. The black hole is not alive. It is not expressing pain or distress. What we are hearing is simply the physical consequence of a black hole repeatedly releasing enormous amounts of energy into the surrounding gas, creating pressure waves that ripple outward through the cluster the same way ripples spread across a pond after a stone is dropped. But understanding the physics does not make the sound any less haunting, because what this sound represents is almost incomprehensible in scale. This single black hole, through its repeated eruptions, has been preventing the hot gas in the Perseus cluster from cooling and collapsing into new stars for hundreds of millions of years. The pressure waves we are hearing, compressed into something audible, are the actual physical signature of one of the most powerful, sustained energy release processes ever observed in the universe. A groan that has been ongoing for hundreds of millions of years. A groan we only learned to hear in 2003. A groan that will likely continue for hundreds of millions of years more, long after every person who has ever heard this recording has died, long after human civilization itself has run its course. This is not a sound that cares whether we are listening. It existed before us. It will exist after us. And in that timeless, indifferent persistence lies the true source of its horror. The black hole's groan is not alone. Across the solar system and beyond, NASA's instruments have captured an entire chorus of unsettling, alien sounds, each one a sonification of real physical processes, each one carrying its own particular brand of dread. Near Saturn, NASA's Cassini spacecraft recorded radio emissions associated with the planet's auroras, its polar light displays, similar to Earth's northern and southern lights, but driven by Saturn's much more powerful magnetic field. When converted to audio, these emissions produce a series of rising and falling whistles, almost musical, almost beautiful, until you remember they represent enormous electromagnetic forces interacting with charged particles at scales that dwarf our entire planet. Around Jupiter, NASA's Juno spacecraft detected something stranger still: radio emissions caused by the moon Ganymede passing through Jupiter's intense magnetic field. The resulting sound has been compared to a dial-up modem from the early days of the internet, but stretched and distorted into something far more menacing, a digital scream almost, generated by raw electromagnetic interaction rather than any human technology. The sun itself produces sounds when its vibrations are converted to audio. Helioseismologists, scientists who study the sun's internal structure through its surface oscillations, have sonified data showing the sun's natural resonant frequencies. The result is a deep, pulsing hum, the actual sound of our entire star vibrating, an organ note played by nuclear fusion itself, far too low for any ear to naturally detect. And perhaps most unsettling of all, the sound of interstellar space itself. NASA's Voyager 1 spacecraft, now over 22 billion kilometers from Earth, carries a plasma wave instrument that detected oscillations in the thin, ionized gas of interstellar space after Voyager crossed the heliopause and left our solar system entirely in 2012. The sound produced from this data is faint, sparse, a series of high, thin tones against an almost total silence, the eerie acoustic signature of the space between the stars, a place no human has ever been, a place where the only sound comes from a robotic spacecraft launched in 1977, still transmitting data back across a gulf so vast that its signals now take over 20 hours to reach Earth. When you listen to these sounds back to back, the Saturn auroras, the Jupiter Ganymede interaction, the solar hum, the interstellar plasma whispers, and finally the deep ancient groan of the Perseus black hole, something becomes clear. These are not designed to frighten anyone. They are simply honest. They are the universe unfiltered, speaking in the only language available to forces that have no voice, no intention, and no awareness that anyone might ever be listening. And that honesty is precisely what makes them so unsettling, because there is no metaphor here, no artistic exaggeration, no horror movie sound designer adding reverb for effect. This is what these phenomena actually sound like once translated into a register our biology can process. And biology, it turns out, has very old instincts about low, droning, moaning sounds emerging from darkness. There is a reason these sounds affect us the way they do. For most of human evolutionary history, sound has meant something living was nearby. A predator moving through grass, a storm approaching, a call from another member of your group. Our brains evolved in an environment where sound carried information critical to survival, and where unfamiliar, deep, resonant sounds in particular often signaled danger. A low growl, a distant roar, a groan in the dark. These sounds trigger something ancient in us, something that exists below conscious thought, in the oldest parts of our nervous system, evolved over millions of years to keep our ancestors alive. When we hear the sonified groan of the Perseus black hole, even knowing intellectually exactly what it is and exactly why it sounds the way it does, that ancient part of our brain does not care about the scientific explanation. It hears a deep, sustained moaning sound, and it responds the way it has responded to similar sounds for millions of years, with alarm. With the unmistakable sense that something large, something powerful, and something utterly indifferent to us is very close by. And in a strange way, that instinct is not wrong. The black hole at the center of the Perseus cluster is real. It is genuinely there. It genuinely produces pressure waves through superheated plasma on a scale that dwarfs human comprehension. The forces it represents are genuinely, objectively more powerful than anything our species has ever created or ever will create. Our fear, in this case, is not irrational paranoia. It is an appropriate emotional response to a true fact about the universe we live in. We are small. We are fragile. We exist in a cosmos filled with forces of such staggering scale and power that even a tiny, translated, scientifically sanitized echo of those forces can make her skin crawl. But here is the other side of that fear. We heard it. We built the instruments, we launched the spacecraft, we developed the mathematics of sonification. We took a phenomenon happening 250 million light-years away, operating on a timescale of tens of millions of years, vibrating at a frequency a billion times lower than anything we could naturally perceive, and we found the way to bring it into our world, to make it audible, to make it real to our senses in a way that pure data on a screen never could be. That is an extraordinary act, not because it makes the universe less frightening, it does not, but because it means we are no longer simply victims of an indifferent cosmos, blindly subject to forces we cannot understand. We are listeners. We built ears sensitive enough and minds curious enough to hear the actual voice of the universe, its hums, its groans, its electromagnetic whispers, and to understand, at least partially, what that voice is saying. The scariest sound ever recorded in space is frightening because it is real, but the fact that we recorded it, translated it, and chose to listen, chose to sit with that fear rather than turn away from it, is perhaps the most reassuring thing about being human. We did not have to listen. We chose to. And in choosing to listen to the darkest, deepest, most ancient sounds the universe has to offer, we prove something quietly remarkable about ourselves. We are not afraid of understanding, even when what we understand is terrifying, especially then.